Now I'm going to take a look at the CCEA A2 Chemistry, Further Practical Chemistry, Practical Booklet A. That's the practical exam that you will actually have to do in class. Now it's worth noting that while all the past papers are in fact 1 hour 15 minutes long, they don't have 5 questions in them, although this specimen paper does. So in 2018, 2019 and 2022 they all had just 3 questions, but they work out to be the same sort of length as this paper. All of them have a total of 30 marks. So if we have a look at the first question here, gives you safety instructions at the top. You should wear safety goggles at all times, and then it tells you you've got a titration to do. So this one was a potassium manganate 7 solution with sodium ethane dioate. Gives you the equation here, which you might need for calculations later on, and it tells you what you're provided with: a solution of the sodium ethane dioate, 4 20 cubic centimetre portions of sulfuric acid, and then potassium manganate 7 solution with a concentration of 0.2 molar. And then it gives you instructions as to what you should do, and really you should follow these just like reading a recipe. So it says rinse out and fill the burette with the potassium manganate 7 solution. Then use a pipette to add 25 cubic centimetres of the sodium ethane dioate to a conical flask. Add a portion of the sulfuric acid to the conical flask. Warm the conical flask to slightly above room temperature. Then titrate the potassium manganate solution against the sodium ethane dioate solution. Then you have to complete the results table, and of course this is where you're getting your marks from. And the marks here on the mark scheme for this particular one came from the following things. So use of starting values to 1 decimal place for the burette gave you 1 mark. Then a rough titration, and they specified what the values should be between. So the solutions are all made up to the specifications of the exam board, and then they have to be made to that, so your value should be within tolerance of what they get. So then the accuracy of the titration value, of each titration value, sort of plus or minus 0.2 of 23.2 cubic centimetres, and there was a sliding scale for that. So taking into account all of those marks you could get, and then working out the average titration where you calculate the correct value, you could get up to 6 marks for that part. Next, explain how you would read the value of the potassium manganate 7 in the burette. So if you remember, it's a very dark coloured solution, so you're going to read the bottom of the meniscus, and 2 marks for saying that. So I imagine 1 mark for bottom and 1 mark for meniscus. Then what's the colour change in the conical flask? Well, it goes from colourless to pink, 2 marks, again 1 for colourless, 1 for pink. So the second experiment here, you're provided with an iron compound. It says carry out the test to determine which iron compound it is and write what is observed in each case. So imagine that you're given a green solid. You have to describe the appearance of the solid. You write it's green. Then dissolve it in water and state the colour of the solution. You get a green solution. Add sodium hydroxide solution to part of the solution. You get a green precipitate. Add dilute ammonia to part of the solution. You get a green precipitate. Add barium chloride, and this is where we get a slight change, we get a white precipitate. And then add silver nitrate to part of the solution, it's no reaction. And then it says name the iron compound. Well, you know it's an iron compound, but obviously they're asking is it iron 1 or iron 2? Or sorry, iron 2 or iron 3. So it's iron 2 because of all the green stuff. And then with the white precipitate here, we know that it's sulfate, so iron 2 sulfate. The third one in the specimen paper was looking at complexes, and it was the depth of the colour of a solution can be used to determine the formula of a coloured complex. In order to do this, solutions of various depths of colour in test tubes are compared with that of a standard solution. So the reverse can be carried out. A concentrated solution of a coloured compound can be successively diluted until the depth of its colour matches that of a known solution. So it says you're provided with a concentrated solution X of copper 2 sulfate of known concentration 5 molar and a solution of unknown concentration Y. Dilute the solution X until it has the same colour as that of solution Y. Now, explain your dilutions by stating the volumes and apparatus used, that and how you compared the colour of the known solution with that of the unknown solution. So the explanation there of how you dilute it appropriately. You just need to explain that you're using the correct apparatus, like measuring cylinders, and then to give examples of how much you're diluting. So to say you're taking, say, 100 mils and adding 100 mils of water, and so on. As long as you're explaining it correctly, you're going to get 2 marks for that. And then the second bit is for explaining how you compare. So it's just by placing the tubes side by side, and it actually tells you that up in the blurb, until one matches the other in intensity. So 4 marks if you got all of those, and the concentration of the unknown solution happened to be 2 molar in this case. Question 4 was by TLC. So Z is an organic substance. Dissolve a couple of crystals of Z in an ignition tube, a third filled with propane. Dip a capillary tube into the liquid and place a spot of the solution on a TLC plate. Let the propanone evaporate. Cut the TLC plate to fit a 250 beaker and place it in the beaker which contains ethanol and has a lid. Allow ethanol to run near the top of the TLC plate. Remove the TLC plate. Leave for a couple of minutes and place in a container of iodine which is in a fume cupboard. Draw a sketch of the result after placing the TLC plate in iodine, then label the solvent front and the starting point. So the way this was marked was you got 1 mark for correctly labelling the solvent front, you got 1 mark for having 2 spots labelled with appropriate sizes at the correct places, at approximately the correct places anyway, and then you got 1 mark for the solvent front being near the top of the TLC slide. And then how many substances are there in Z? Well, you would have seen 2 spots if you'd actually carried out that experiment, so 2. And finally, the 5th question here is about different ligands. So we've got 3 solutions, L1, L2 and L3. One of them is monodentate and the others are bidentate and polydentate. All of them form complexes with copper 2 ions. So complete the table which shows the competition between the ligands. Each box in the table should have a description of the change of colour or lack of change of colour which takes place when the solutions are mixed. The greater number of solutions will lead to the ligand with the greatest denticity. So I've just ticked here the ones that you would see reactions in. So copper 2 with ligand 1 would give you reactions with 2 and 3. Then the second one here would just give you a reaction with ligand 3, and the third one would give you no reaction at all. Now the way that was marked was looking for appropriate colour changes being recorded and the fact that you had 3 positive and 3 negative results. So just looking for the correct results. Now obviously I've just ticked, but in the exam you would write in any colour changes that you observed. So that's really all you have to do in these, is to put in your observations. Make sure if you're calculating average titers or anything like that, that you're doing it carefully and you're not using the rough titer. You're only using your 2 accurate ones. Make sure your accurate titers are concordant with each other as well. Okay? Thanks for watching.